Hi, welcome back. This is Dave, and I'm here again today to talk about some audio equipment. And I want to thank all of the viewers that have seen it so far, and I also want to thank you for your comments. I loved your comments, and it's great to hear them and see them. So in the last video, we talked about preamplifiers. In this video, we're going to talk about the next typical step in an audio setup, which is the power amplifiers. So the power amplifier has a lot of specifications which require a ton of mathematics and engineering, which somebody else would be better able to explain than I can. Instead, what I want to talk about is what the specs are and what they mean to the typical user. So before I do that, I want to just step back a little bit to how the power amplifier developed as a separate component in an audio system. So we go back to the 19-teens and very early 20s. Radio and electronics was all experimental. Radio was completely experimental at that time. You had stations broadcasting, and you had listeners with a lot of experimental equipment. But that was about to change. The 1920 election of Warren Harding and James Cox was broadcast live by station KDKA in Pittsburgh. And it was revolutionary because until that time, a typical American citizen waited till the next day to hear the results when they got it in the newspaper. But anyone with a radio at that time knew immediately the election results. Well, that was quite revolutionary, and it did a lot to push the radio concept as a typical home appliance. One of the first manufacturers to offer a radio that would be usable easily to an average consumer was RCA. And the first model, it's considered the first home radio, was called the RADA. And it was sold as a combination. The RA was the receiver, the DA was the amplifier. They also sold it as a model called the RC, where they literally had attached the two together mechanically. But it still had a separate amplifier. It was cumbersome. Most Americans wanted to just plug in a radio, hook up an antenna, and listen. And as a technology advanced, manufacturers are able to offer that. So for most American consumers, they bought a radio, they plugged it in the wall, and they could listen. Inside the chassis of that radio would be two distinct electronic portions, the receiving portion and the amplifier portion. And two high-end manufacturers emerged, E.H. Scott and McMurdo Silver, that made radios, but not for the general consumer. They were way out of reach. They were incredibly expensive. This was the middle of the Depression, mid-30s, middle of the Depression, not in reach of the average consumer. But it still had a market in the high end. And in their radios, it looked from the outside to be a typical standard floor radio, but inside, the amplifier chassis was actually separate from the receiver chassis down in the bottom of the case. They also coined the term high fidelity at that time because their equipment could produce, at that time, the highest fidelity possible. As the components improved and manufacturing techniques improved, that higher quality would become more available to the average consumer. And the manufacturers would offer even better quality, even lower price, better capacitors, better tubes, better transformers. And the industry evolved so that people would demand better quality. So after the war and through the 50s, manufacturers began to actually offer separate components, much as the highest end components had in the 30s. Again, not even at that time for the typical user, but mostly for the high-end user, but it was still within reach of consumers at that point, more than the very highest end had been in the 30s, 20 years before. So what emerged are several configurations. The power amplifier on its own as a standalone, the power amplifier combined with a preamplifier, which is called an integrated amplifier, and the power amplifier combined with a tuner and a preamplifier, which is called a receiver. So those are the typical arrangements. And now let's take a look at the specifications. So in no particular order, one of the first specifications you often see published about any amplifier is its frequency response. So what is frequency response? Frequency response is a range, and it's always listed in cycles per second or hertz. That means the same thing. And basically it's the range that the device can reproduce. The human ear can hear roughly from 20 cycles per second to 20,000 cycles per second. Obviously some can hear more and less, but that's the range of the human ear. So anything that's able to reproduce within that range is excellent. So frequency response, you want the widest range possible, and pretty much every modern amplifier can reproduce a fairly flat response from 20 to 20,000 cycles per second. But that wasn't so back in the 30s and the 40s. In those days, engineers were trying to get past 12,000 cycles per second. But better tubes, better capacitors, better transformers, all brought the frequency response range. So every good modern amplifier has a very acceptable frequency response. So it's not a really important specification to worry about. The next popular specification you always see published is THD, or sometimes just distortion. And THD takes in a few different kinds of distortion because there's a lot. But what is distortion? It's measured as a percentage, and you want the number to be as low as possible. But what distortion is if you look at the waveform, input from the amplifier and the waveform output from the amplifier, ideally they should be identical, but they never are. You've got all of these tubes and capacitors and transformers for the signal to go through in order to get bigger. So no matter what, the output waveform is going to differ a tiny bit from the input waveform. That can be measured. It's measured as a percent. And all modern amplifiers are under 1%. And many of them are under 0.5%. That's excellent, and it's very low figure, so it's not critical to worry about the distortion as one of the specs of an amplifier. Yet another specification you see published is called SNL, or sometimes you'll see S/N, or Macintosh calls it noise and hum. It all means the same thing. SNL stands for signal to noise level. S/N means signal to noise ratio. Basically, it's this. Every electronic device has an ambient floor of noise that is unavoidable. You've got all these electrons whirring around. You've got a power supply that's got to filter out the 60 cycle hum from the AC power line. All of these things are adding to a threshold level, a floor of sound. And we want that sound floor to be as low as possible compared to the pass-through of the signal. So as the signal's passing through, we want to keep the noise as low as possible compared to the signal. So the SNL, the signal noise ratio, is always listed as a decibel. All right, you want the number to be as high as possible because we want as high a signal as we can compared to the unavoidable noise level of the equipment itself. Most amplifiers have a very acceptable signal to noise level. Anything over 60 is excellent. Most are over 80. That's excellent. So again, it's not one of these really critical specifications to worry about. So the final spec, and the one that really matters, is power, an amplifier's power. So power is measured in watts. And a watt, as part of Ohm's law, is fairly straightforward. But when it comes to measuring one in an amplifier, there's a lot more to it, because you've got the power at a certain driving level of the amplifier under certain frequency ranges, frequency response, all sorts of different conditions. So power is often now measured, stated as watts RMS, and that's just a way to standardize the measurement of watts. And the reason that that's important is because early in the audio industry, it was popular for manufacturers to overstate the performance of their amplifiers in power. And Macintosh actually famously did just the opposite. They understated what their amplifiers could deliver in power. And so as an example, the MC240 is a 40-watt amplifier, but at the amplifier clinics, and they loved demonstrating this, it was fun to go do this. So I was at the amplifier clinic October 3rd, 1988. And here's Dave O'Brien's initials with 52 watts per channel. So this 40-watt amplifier, it even, a few years old then, was able to produce 52 watts, so almost 20% over its stated value. Here's why that's important. When an amplifier is nearing its max limit, the waveform is traveling like this. If it goes above and below its max limit, it's called clipping. It literally clips off the top and bottom of the waveform. And what happens there then is it sounds terrible, you'll hear it, it sounds horrible and garbled, all right? But it's also not allowing the voice coil of the speaker to cool down. And the voice coil of the speaker will run very hot and you can burn it out, sometimes pretty quickly. So if an amplifier is too low a power, it will be driven into clipping and you can damage your speakers. So what matters about power is that you always want it as high as possible, that your budget and size will allow. So always go for the higher power amplifier when in doubt, because you'll have more choices for speakers, because a more efficient speaker can be used with a lower power amplifier, but less efficient speakers need more power. So when you build a power amplifier into a speaker, they call them active speakers, you don't have to worry about it as much because the manufacturer knows that the speaker's sensitivity is going to match well with the amplifier they've built in. But anytime that amplifier is separate from a speaker, you need it to match well with the speakers. And we'll talk more about that in a speaker episode with speakers and their SPL. But what really matters is get as much power in watts as you can. So I hope you've enjoyed this. I've had fun doing it. I really have enjoyed your comments. I love hearing your comments. Please keep them coming and look forward to my next video. Thank you very much. Have a great day.